Did you know that antimatter is created in bananas? It's also created in nuclear reactors and other radioactive substances as well. When it comes to bananas, I'm talking about the radioactive potassium that's in them. So let's talk about how antimatter is created in nuclear reactors and from radioactive decay. What I'm talking about here is called pair production and electron-positron annihilation. This generally starts with a large nucleus of an atom with a lot of protons and neutrons. What happens is when you have a high energy gamma, and I'm going to create it with a high frequency here, comes in and interacts with this large nucleus, it will, or pair production will happen, where you have an electron and a positron that's created, both traveling away with some energy. What happens is this electron is going to keep going and it's going to interact with the other electrons in the nearby atoms, or maybe even of the atom of this nucleus here. It's going to impart some of its energy, it's going to release other electrons, and eventually the electron will slow down and be captured by another atom. This positron is going to interact very differently. Here we have an electron from a nearby atom. This positron is not going to travel very far. That positron is going to come in, and they are both going to feel each other. That's because a positron is positively charged and an electron is negatively charged. So when you have differing charges, they tend to attract each other. And that's because the positron is the antimatter version of an electron. Now, positron is called positron because it's positively charged. Electron, sometimes you can call it a negatron because it's negatively charged. So as this positron comes in and interacts with this electron, they're both going to start to spiral around each other. As they spiral, an interesting thing that happens is that these electrons and positrons are going to start also emitting lower energy gammas off of it as they're spiraling in towards each other. They spiral in, and basically they're giving off energy as they're spiraling in the form of these photons here. This one's going to keep spiraling in, and then they're going to meet in the center. And that's where annihilation happens. What happens during annihilation is that two photons are created at equal energy, traveling the opposite direction from each other. And what you see here is a great demonstration of E equals mc squared, where all of that mass, the m, is converted into energy. So the energy of these photons that was created is exactly the mass equivalent of one of these positron or electrons. They both weigh the same amount. In the beginning, I talked about how there was a high energy gamma that came in and interacted with that nucleus. That high energy gamma had to be twice the amount of energy as two electrons. That's because you had to produce both a positron and electron. And that is how antimatter and matter are created and destroyed in a nuclear reactor and in some radioactive substances.